Alright, let's do this. Part 2. Okay. Derivatives. Product rule, quotient rule, integral? Integral. Oh, that one looks good. Alright, let's do it. I call that u. I'll call that v. D on dx is equal to vu dash plus uv dash. V is ln x, u dash is 2x, u is x squared, v dash, the derivative of log, is derivative over original. There's only 1 mark, so really that's enough. But let's keep going. 2x ln x plus, that's going to go and that's going to go x. You could factorize that, but look, it's 1 mark. Stop. Okay. Quotient rule. U, v. Just check for, like, obviously whether you can simplify it first, but I can't because that's a trig in a disgusting set of brackets. So let's go. D on dx is v u dash minus uv dash all on v squared, which is, this is going to be interesting, v 2x minus 3 squared, u dash is the derivative, so 2 cos 2x minus u, which is sine 2x, times v dash. Wow, okay, so this thing in here, so I'm differentiating this. The 2 comes down, oops, 2 comes down, 2x minus 3, I drop the power so it's a 1, and then I times by the derivative, 2. All over v squared, which is 2x minus 3 squared, which would be to the power of 4. Alright. Okay. In terms of simplifying this, you'll notice that I can get rid of so I can get rid of this, one of those, and one of those. That's nice. So then I've got 2x minus 3 outside of 2, let's put the 2 out here, cos 2x minus, I'm going to times the 2's together, so that's 4 sine 2x, all on 2x minus 3 power of 3. And look, that's as far as I'd go. It's only 2 marks. Okay. Find the following integrals. So it's weird with the on 2, so I guess just rewrite this as 1 on 2 sine 4x minus 9. Might as well just take that out. Okay, so then it's half, the integral will be negative cos, keep what's in there, and then I divide by the derivative. So divide by 1 on 4. So then let's write that as half, wait, divide by the derivative. Dividing by 1 on 4 is the same as timesing by 4, isn't it? No. Oh yeah, no, I'm timesing by a quarter, sorry. Okay, so then I've got 1 on 8 as a minus cos, Jesus, Xander would have killed me. Okay, is that right? About right to me. Okay. Wowzers, this thing looks fun. Okay, I'm thinking derivative over original. Let's factorize the top. Okay, top 2 outside of ex minus 2x, all on e to the x minus x squared. You'll notice that the derivative of the bottom is on the top. So if I bring this 2 out, e to the x minus 2x on e to the x. Okay, so what you've got to recognize here is that if I differentiate all this, so if I differentiate this, I get this. If I differentiate this, I get this. So therefore, it's derivative over original. So this is in the form f derivative over original dx, which is equal to ln fx. Okay, and now fx in this case is the bottom, which is e to the x minus x squared. And I'll put a plus c on there. It doesn't say simplify, it's only 2 marks. Yeah. The question in the answers has bounds. Oh, no, it doesn't. No, it doesn't. That's the next question, sorry. Okay, these need to be absolute values. That needs to be like that. Yeah, we're good. Okay, continuous random variable, probability density function. It's 2 on x, and it goes from 2 to a. Can't hurt to draw it. I'll just go 1 on x as a log, so 2 on x looks like this. That cuts at 1. No, that'll cut at 2, so 2 to a. So then this area here, for it to be a probability function, needs to be 1. So find the value of a in the form b equals bec for some real numbers b and c. Okay. So I need to be able to integrate this function. So 1 needs to equal the integral from 2 to a 2 on x dx. Just make sure I'm setting that up right. Yep. So in other words, this area, the area under the curve, that curve is this, needs to be 1. So that's y equals 2 on x. So now just keep going. So I integrate that. Actually, I need to bring the 2 out. So 2 to a 1 on x dx. So again, I've just noticed the derivative over original. So it's going to be 2. Let's divide the 2 out. So it's going to be a half. Ln x from 2 to a. So that equals ln a minus ln 2, which is ln a on 2, and this equals a half, and that's an absolute value. Good so far. I forgot a plus c. Oh no, I didn't. Don't need a plus c. That'd be silly. Okay. Now I need to get a by itself. Okay, I shouldn't have done that actually. That's a half. So let's get the ln a by itself. So ln a, I'm going to move everything else. So half plus ln 2. So then a is equal to, so if I take the e of both sides, that's going to be e half plus ln 2. Okay, let's keep going up here. Gotcha here, fill out. So that's e to the half times e to the ln 2, which is e to the half times 2, which is 2e to the half. Okay, that was weird. Anyway, next one. I really hope we're streaming. I didn't even check. Might check. Okay, find the cumulative density function of x. Include the domain when writing it. Include the domain. Okay, I can do that. Alright, so in order to do that, you just basically do exactly the same thing, except you go from 2 to some value x. So this is obviously the bound. Now I want to find any value, so I use x, and I go, alright, well, my CDF is the integral from 2 to x. I can't really use x twice. Let's use of, it says of x, so I have to use x. Let's just use capital X and little x. 2 on x dx. Now, from above, we already did that. That's all of, well, this. So this is equal to ln x minus ln 2, and you can just write from part A, include the domain. Okay, is that it? Oh, I forgot the 2 out the front. Did I forget? Oh, no. I just remember in the last one I moved the 2 out the front and then I moved it over here. So I haven't put that back. So that's that 2 there. And that's it. It asks for the domain. So, domain just means where does this thing exist? And we know where it exists. We drew it. So it goes from 2 to A. So it goes from 2 to A. But we know that A was equal to 2e to the half on the last question. So really it goes from there to there. It just means it goes from 2 to that. And that's it. Alright, find p of x when it's bigger than e. So e is, I guess, a number. Did I give... No, I didn't. Okay. So, a couple of things to note. First one is if it's greater than e, remember that when you're finding the area of these things, it's going from 2, pretend this is e, it's going from 2 to, let me just draw a bloody thing. Here's my thing, looks like this, from 2 to 2e to the half, e. If I find the integral from 2 to e, that's going to give me this, but I want it greater than e. So what I want is this. So in order to get that, I'm going to have to go 1 minus the integral of 2 to e. Actually, you could go from e to 2e half. You could probably do that. There's 2 ways of doing this question. That's kind of cool. I was thinking I could do 1 minus this part, or you could do this part. Wow. I kind of want to test both. Okay, let me just write it. You've got, so this. Oh, okay. The reason you would do this one is because you've already figured out the integral here. Otherwise, you'd have to do it. Oh, it'd be the same though. Just the bounds would be different. Yeah, okay. So it'd be that, or you could go integral from e to 2e to the half. Then you'd have to integrate it again. So I'm going to do this one. 1 minus, and it's 2 outside of ln e minus ln 2. 1 minus 2. The ln e's just cancel, so that's just 1. I've got to be careful here. 2 outside of minus ln 2 equals 1 plus 2 ln 2, which is around about 0.386 apparently. Okay, that's a cool question. I like that. These ones, yeah. All right, hiking group walked 8 kilometers from camp. So camp, they walked 8 kilometers on a bearing of 230. So that's 230 to point A. They then walked 6 kilometers on a bearing of 15. So that's 15 in there. The diagram shows their path. Complete the diagram and find CAB. Okay, so CAB. So I want this angle. Let's call that theta. All right. In bearings, parallel lines are your best friends. So here, I'm going to know what this is, and that's going to help me find this. So then I've got co-interior. So the angle NCA. So angle NCA is equal to 360 minus 230, which is 130. What can we call that? Angles at a point. In a circle. Angles in a circle. I don't know. There's our justification. So that means this here is 130. Angle, so now I'm going to make this argument. This angle is co-interior to this angle. So angle NA, I'm going to have to call these things, that's N1 and that's N2. N1, N2, NA, N1 is equal to nanny. So this, wait, yeah, no, that's C. NAC is equal to 180 minus 130, which is 50 because of co-interior. Okay, this implies that that implies that theta is equal to 50 minus 15. So this is equal to this minus this, which is 35. Oh god, that was interesting. We can use the adjacent because they're next to each other. Right. How far must the group walk to return to the camp? Okay, so where are they? They're at B. So I'm looking for this distance here. Call that D. Looking at sine rule. I've got this. Oh no, I don't have this. But I have length, angle. Okay, so I've got two sides in the Euclid angle. I can use the cosine rule. So D squared equals let's call this A, B, and that's going to be capital D. A squared plus B squared minus 2AB cos D, which is 35. Damn it! If that was a nice number, we could have had this nice, but oh well. All right, so that is. Oh, surely I have the right working. Minus 268. Yep. Okay, so that's around. Mosquito. So 21.36. Blah blah blah. D equals the square root of that, which is around about 4.6, and it's in kilometers. Right. How many questions are we doing? Not that many. Wow. We're flying. 17 minutes. Okay, Kurt has gathered data from various locations on N, a number of new cases of a new virus. Since the number of days the outbreak started. Okay, he's got a correlation coefficient of 0.9. Okay. So he's suggesting that that's a 0.9. Sure. The equation aligns in that form. A is that's the y-intercept. Cool, so that's negative 24 there. Find B to one decimal place and explain the meaning of B. Is there a solar flare coming through my window? Find B to one decimal place and explain the meaning of B in the context of the variables. Okay, so I know that N is equal to minus 24.7 plus BT. So all I did was chuck that in there. Now, I've got a real. Oh, I don't really have an obvious choice, do I? Okay. 1T. Okay, my goal is to find a 100% point on the line. I'm looking at this one. That, not this circle. I'm looking at this. It appears to cut perfectly here. I say appears because there's going to be some margin of error. So the point. So where was it? This one. The point 420 is on the line. I'm suggesting 420. So then I go. So what I'm going to do is substitute that and solve it for B. So this here is T, and that's N. So then 20 equals minus 24.7 plus B times 4. That's going to be 44.7 equals for B. That means B is equal to 44.7 divided by 4, which is 11.175. It says to 1 decimal place, so which is approximately equal to 11.2. Jesus. The meaning of B in context of the variables. Okay, so what is it? The number of new cases, the number of days since the outbreak. So that means for every... So B is the gradient. So every day there's 11 new cases. That's what that means. So therefore every T, so day, there are 11.2 new cases. 100% this has been done right now in our current world. What is the predicted number of cases 15 days after an initial outbreak to the nearest whole number according to their least squares linear regression model? Wow, that's a lot of words. Literally, all that says is when n equals... Wait, what is the number of cases? Yeah, so what is n when t is equal to 15? That's literally all that's saying. So using the model, n equals minus 24 point... There's only one mark. Plus 15... No. What's b? 11.175 times 15. And that's equal to 146. All I did was put... So I'm using this. I put b in there, and then I put 15 days in there. That's all I did. So 146 watt cases. Surely Gladys is doing this right now. And you can kind of tell if that makes sense. Actually, it's a little bit far. So 15 would be like out here. Would you be suggesting that up there is about 146? Yeah. Anyway, Coach Frank Muhammad thinks that an exponential model fits better. Good for him. Do we reckon? Or maybe. He uses a stat program to find that is the exponential model. Graph it on the scatter plot above. Wow, that's pretty mean. Graph it. Oh, that means I need a table of values. Okay. It doesn't say sketch. It does say graph. So let's go Tn. Let's go from, let's just do the values it's got. 0, 2, 4, 6, 8, 10. 0, 2, 4, 6, 8, 10. Okay, now when you put a 0 into here, that's going to be 1. So this is 2 point, let's go 1 decimal place. This is 2.8. That's easy. Actually, no, screw it, I'll do it later. 2.795 times 2 to the power of 0.525 times. And I just keep replacing this. So times by 2 is 5.8. I put 4 there. It's 11.9. That's actually 12.0. Put a 6 there. It's 24.8. Put an 8 there. I'm missing a 1 there. Put an 8 there. It's 51.4. And I put a 10 up there, and it's 106.4. So then I just need to graph each of those points, let's do them in red. So 0 to 2.8. That's going to be like there. 2, 5.8. 2, 5.8. That's going to be there. 4, 12. 4, 12. Call that there. 6, 24. 6, 24. There-ish. 851. 851 there. And 10, 106. 10, 106. So then it's going to look kind of like I'd say use a ruler, but that's kind of a stupid thing to say. Okay. Do you reckon that fits the do you reckon that fits the data better than the straight line? Maybe. Okay. What are you up to? Not long left. How many... Oh, geez, it's still going. How many cases does Muhammad's exponential model predict at 15 days? Okay. Oh, well, I can't look at the graph now, can I? Got to look at the model. I think I still have it, damn it. 2.795. Was it times 2 to the power of 525t? 525. God, I'm good. Just kidding. So when time is 15, n equals 2.795 times 2 to the power of 5. Oh, it's 0 point. No, I'm not good. Times 15. Damn it, I should have left all that in there. 2.795 times 2 to the power of 0.525 times 15. That's 5. 656.1. Is that right? Yeah. Okay. Now what's it say? Explain the difference in their predictions. Oh, I did the right one, didn't I? Yeah. Oh, 15 was before. Did we do that before? Yeah, we did. Okay, so before he said... So Kurt said 146 cases. Muhammad now said 600. Wow. Okay. So Kurt was it 146? 146. And Muhammad is 656. So they're quite significant. And the limitation of their predictions, well, I guess the main thing is that they're both regression models, and we don't have any values up to 15. So, like, I mean, we could have it like this. The graph could look like this. Who knows? We don't know what it looks like here. So the limitation of the model is that it's a regression model, and we don't know what happens beyond our data. So beyond the given data. If it asked us to make a prediction within the data, so if it said like, what happens when t is 7, then you could use the data to model that, and that wouldn't be very limited. Like, that'd be pretty accurate. But because it's outside of our data, we don't know what happens. So that would be the limitation. So if you're literally to write something, you could just say something about regression. Okay, is this the last one? Yeah, okay. The water level in estuary is cyclical, with a maximum depth of 5 meters, a minimum depth of 2 meters, and the cycle repeats every 12 hours. I feel like I want to graph that first. If the last high tide was at 2 a.m., use a sine cosine function with transformations. So that kind of means I can use whatever I want. So I guess you just got to make a choice as to whether you want to use sine or cosine. Where d is the water depth and t is the hours since 12 a.m., the function should be in that form. Okay. Oh, so they've told us it has to be cos. Okay. No. So they've told us it's cos. Now it says that the last high tide was at 2 a.m. and the depth is, so it's how many hours since 12 a.m. So the graph starts at 12 a.m. Oh God, I want to draw it. What does it want in this part? The function should be in the form. Am I just writing it? Yeah, I am. Okay. So d is equal to, I kind of want to draw it first. This. Okay, so t, it's in hours. So 12 a.m. is the same as midnight. So this is 2 a.m., 4 a.m. I don't know if I want to do that. Let's leave that for a second. What's the height? It's got a maximum depth of 5 meters. So that's 5. And the minimum's 2. Okay, I need to move this. So down here it goes down to 2. Okay, so this tells me that the amplitude So see how it goes from 5 to 2, minus 2, whoops, is, so 5 minus 2, and then you halve that. Half of that, so that's half of 7, so that's 3.5. Okay, so that means at the halfway point it goes up 3.5 and it goes down 3.5. So that's k. So that equals k, the amplitude. Now, it's been raised, so it doesn't go up to 3.5, it actually goes up to 5. So c is equal to, so if this was at 0, the middle point, if it went up 3.5, then the difference is, so like if this was 3.5 and this was, whoops, minus 3.5, then how far up has it gone? So how far up here? That's 1.5. What else can we find? Let's start filling this in. D equals 3.5 cos stuff 1.5. Okay. I'm just going to start drawing it. So you can see that trig is my favorite thing ever. And the cycle repeats every 12 hours. Okay, so that is the clue for the period. So that means I need to put 12 hours on here. Let's call this 12 p.m. Let's bring 12 out a little bit. So it's a cosine graph. Its high tide is at 2 a.m. So that there, if that's 2 a.m. Now it does its cycle every 12 hours. So that means at 14, it'll be at the top again. Okay, let me just do a quick. Cos looks like this, which means halfway between 2 and 14 is what? 6? No, 4, 8. Gotta hope that's right. 8, it's going to have a low there. Oh, that's not bad, look at that. Oh, graph in the domain 0 to 24, I didn't see that. Bugger. It's okay, hold on. And another 12 will give me 26, right? I feel like this is taking me too long. What's this low going to be? So that's 14. Then this is between 14 and 26. So 6 plus 14, 20. That's 20. Okay. So the period. Oh, I need to draw this. That's a pretty good graph. Is that right? That has to be. Yeah, that's not bad. Okay. Yep. Alright, so period. It's always 2 pi on n. Our n in this case is when it repeats. So that's 2 pi on 12, which is pi on 6. Okay, so that means I've got pi on 6 here. And then t plus, the very last thing. And this is how far it's been moved left and right. And you can see that it's been moved to the right 2. So that means I've got a minus 2. I've just done it. I've done it. Is that right? I don't agree with that. 1.5. I've got these the wrong way around. I thought I was confident with that. I've got these the wrong way around. Are we sure about that? How? Amplitude is 5 minus... Did I write minus 2? Does it not even go under? Am I stupid? Oh, a minimum of 2, not minus 2. Oh, you idiot. It's okay. Damn it! Damn! It's okay, it's okay. So that's actually 2, not minus 2. Which means all of this has to come down. Actually. Ah, damn! That's 2 there. Gotta suck a trig. Oh, actually, can I do this? No, I can't do that. Easy mistake, I guess. Look, I thought I was on a roll. I just misread the question. Anyway. Okay, so then if it starts at 2, goes to 5, what's halfway between that? 1 is at 1 point, so, okay. That'd be 5 minus 2, which is 3, so that's 3.5, oh, what? 3, no, 3, half of 3, 1.5. Okay. And then, if it was at 1.5, so if it went up to 1.5, what's my difference now? That's 3.5. This is going to take half the video. Okay, we got there. Have I wasted the whole thing? No, I haven't. Good. Look, I could restart this, but I feel like it's good to see me make mistakes. And how you bounce back from them. But also, you can notice that we're only at 40 minutes, and I spent like a long time on that. And I've still got 20 minutes left to make it up. Okay, when is the first time after 12 p.m. the low tide will occur? So now that I've got the graph, that should be super easy. The first time after 12 p.m. So this was 12 a.m. That's 12 p.m. When will the first low tide occur? What's defined as a low tide? I need to be careful. There's a low tide when it's at the very lowest point. I guess so. That's 20 o'clock. So 20 o'clock, which is 8 p.m. So see how 2 a.m. 12 a.m. is here. 2 a.m. high tide, 8 low tide, 12 p.m., 14, 2 p.m., and then 8 p.m. 24 hour time, God. Yeah, it's only worth 1 mark, so you just need to read it off the graph. What is the rate of change of the water level at 12 p.m.? Well, that's nasty, isn't it? Rate of change implies derivative. So the derivative, are we using F's and X's? I'm using D's. Okay. All right. D equals, let's copy this, eh? Okay, so dt is 1.5 cos becomes negative sine. So negative sine, just put big brackets around here. Let's just keep that pi on 6 I should probably expand that. Okay, let's just expand it in here. Minus pi on 3. I've just expanded the middle part, that's all. The end goes, and then I've got to times by the derivative. The only reason I expanded that was so that I know that the derivative is pi on 6. Okay, so then I've got, oh jeez, minus 1 point, let's write all of this, minus 3 on 2 times pi on 6 sine pi on 6, and then I'll fix this. Okay, so then this is that goes, and that becomes a 2. Am I tripping? No. Okay, so then that's minus pi on 4 sine pi on 6 t minus 2. Okay, now at 12 p.m., so when t equals 12, the derivative or the rate of change of d with respect to t is this pi on 6t. So 12 minus 2 is 10. So let's write that as 10 that. Do I need to type that into the calculator? Okay, well when you do, you get 0.68. Okay, now that's meters per hour. So that means every hour the rate of change at 12 p.m. So that's, you'll notice that it's a positive value because at 12 it's increasing. So I've got a positive gradient. So it's increased. So from here, it's instantaneously increasing by 0.6 meters per hour. So here at 13, this should be 0.6 higher. So the fact that I took the derivative here, I got a positive. If I took the derivative here, I'd probably get a negative because it's decreasing. Are we done? Oh, we're done. Okay. Time for the actual hard questions. 42 minutes. That's not too bad. I'll take that.